Imagine a dark sky illuminated by vibrant lights, dancing like moving curtains in shades of green, purple, red, and blue. It feels like something out of a fantasy story, but it's real and happens right above us on our planet Earth. This is the phenomenon known as the Aurora Borealis, or, in the southern hemisphere, the Aurora Australis. Today, we're going to explore the science behind this cosmic spectacle, the best places to witness this incredible phenomenon, and some fascinating facts you've probably never heard before. And what if I told you that these magical lights are directly connected to our Sun and the Earth's magnetic field? Let's dive in and discover how they work. Auroras are luminous phenomena that occur in the polar regions of our planet. They are caused by the interaction between charged particles from the solar wind and gases in the Earth's upper atmosphere. Sounds complicated? Let's simplify it. It all starts with the Sun. Our star is constantly releasing charged particles, known as the solar wind. These particles travel at an incredible speed, around 1 million miles per hour. When they reach Earth, the planet's magnetic field acts as a shield, deflecting most of these dangerous particles away from us. But something special happens at the poles. There, the magnetic field is weaker, allowing some of these particles to enter the Earth's atmosphere. This is where the magic begins. When these charged particles hit the atmosphere, they collide with atoms of gases like oxygen and nitrogen. These collisions release energy in the form of light, creating the incredible visual effects we see in the sky. The color we see depends on the gas involved. Oxygen produces green and red hues, while nitrogen gives off shades of blue and purple. You might be wondering, why do auroras only happen at the poles? It's all due to how the Earth's magnetic field works. Imagine the Earth as a giant magnet with two poles, north and south. The magnetic field is concentrated in these areas, creating a sort of entry point for solar particles. That's why the northern lights or Aurora Borealis are visible in places like Norway, Finland, Alaska, and Canada, while the southern lights or Aurora Australis light up the skies over Antarctica, Tasmania, and parts of New Zealand. Did you know that auroras can even be seen from space? Astronauts aboard the International Space Station have a privileged view, where auroras appear as glowing rings around the Earth's poles. It's an entirely different and absolutely fascinating perspective. Auroras aren't exclusive to Earth. Planets like Jupiter and Saturn have their own versions of this phenomenon, thanks to their magnetic fields. However, unlike our auroras, theirs are mostly generated by gases like hydrogen. In ancient times, auroras inspired many legends and myths. For the Vikings, the lights were reflections of the armor of celestial warriors known as Valkyries. In some Inuit cultures, auroras were believed to be the spirits of people dancing in the sky. If you dream of seeing an aurora in person, here's the good news. There are plenty of places where you can make that happen. In the northern hemisphere, the Aurora Borealis is most visible during the winter months when nights are longer. Places like Tromsø in Norway and Fairbanks in Alaska are famous destinations for aurora hunters. In the southern hemisphere, the Aurora Australis can be seen in parts of Tasmania and New Zealand, but also in Antarctica for the more adventurous. The auroras are more than just a visual spectacle. They remind us of how our planet is connected to the cosmos, a small piece of a much larger and more mysterious universe. If you ever get the chance to see these magical lights in person, it will be an experience you'll never forget. Did you enjoy learning more about auroras? Share in the comments what fascinated you the most and whether you'd like to see this phenomenon up close. Don't forget to like this video, subscribe to the channel, and turn on notifications so you won't miss any amazing content like this. See you next time.